Ladies and gentlemen, we'll get started. I'm Sarah Scheib. I'm the Sciences Reference and Instruction Librarian at the University Libraries, and it's my pleasure today to introduce the speaker, Dr. Jeff de la Beaujardiere. Thank you. Jeff has been the NOAA Data Management Architect since 2011 and chair of the Environmental Data Management Committee since 2012. He also serves on interagency and international groups aimed at enhancing data sharing and interoperability, including the International Group on Earth Observations Data Management Principles Task Force, the U.S. Group on Earth Observations Data Management Working Group, and the Open Geospatial Consortium. In these roles, he works toward the vision that NOAA's rich and unique data holdings shall be discoverable, accessible, well-documented, compatible, and preserved for future use. Previously, Jeff was Senior Systems Architect for the U.S. Integrated Ocean Observing System Program Office at NOAA, where he guided the implementation of interoperability standards by IOOS Partners for Data Access and Discovery. Prior to joining NOAA, Jeff spent 13 years at NASA Goddard Space Flight Center in roles such as Geospatial One-Stop Portal Manager, Web Services Developer for the Modeling, Analysis, and Prediction 2005 project, the GLOBE program, and the Public Use of Remote Sensing Data program, and NASA's representative to OGC and to the Unidata Policy Committee. He participated in the first OGC web mapping testbed in 1998, implemented the first web map server at NASA, and was editor of the WMS specification for the OGC and the International Organization for Standardization. Dr. de la Beaujardiere holds a BA in physics from the University of California at Berkeley and a PhD in astrophysics from the University of Colorado at Boulder. Please join me in welcoming Dr. de la Beaujardiere.
We should maybe turn this one off.
Thank you.
All right, great. Still getting some feedback? I don't know if it's
Maybe turn that one off and turn this one on.
All right, great. Well, thank you, Sarah, for that introduction, and Sarah and Marina for the arrangements for having me come here, and thank you all for being here. I really appreciate it. It was a good opportunity. I haven't been to Iowa since driving through in '85, so it's nice to be back. And I was just reading a book telling me that I-80 is actually along the path of something that was maybe called the Lincoln Highway, started in the beginning of this century as one of the first roads. So that was kind of timely to have got that book on my Kindle just for this trip. So as Sarah said, I'm Jeff de la Beaujardiere. Thank you for your very good pronunciation. Most people don't manage it that well. And I want to tell you about open data from NOAA, what we're doing to make that happen. Also kind of new policies for grantees, and some of you may be grantees. Also talk about our big data project that's happening. So, and I think I'm going to leave enough time for questions. I think we have an hour total, right? So in case you don't know, just a couple words about NOAA here. National Oceanic and Atmospheric Administration is what it stands for. You've probably heard of the National Weather Service. That's probably the most famous part, but we also have Ocean and Atmospheric Research, NESDIS, which is the satellite service, the Ocean Service, and the Fisheries Service. And the mission, I'm going to quote here, is to understand and predict changes in climate, weather, oceans, and coasts, to share that knowledge and information with others, and to conserve and manage coastal and marine ecosystems and resources. So I'm more focusing right now on the sharing the knowledge and information part. I got this slide from the NOAA 101 briefing that's on our public affairs website, showing that there's actually NOAA facilities in every state and territory in the country. And so I looked up, there's a link at the bottom where you can see what's in your state. I think it's mostly designed for senators and congressmen to make sure there's stuff in their state. But turns out we have a geodetic advisor, so that's a NOAA employee who works with the state on geodetic issues. weather forecast offices in Davenport and Johnston, and then various observing and monitoring stations in the state. So NOAA is here in Iowa, although our biggest facilities are in Silver Spring, Maryland, where I'm from, Asheville, North Carolina, the head of the archives, Boulder, Colorado, many other places, but those are some of the key ones. All right, so NOAA, to fulfill this mission, gathers a lot of data, and I think it really qualifies as big data in the sense of big volume, a lot of variety, velocity in the sense of timeliness, rapid acquisition and delivery. We have 10 satellites. We're about to launch a new geostationary satellite next year, 150 weather radars, networks of buoys, tide gauges, humans going out and observing and counting things, sensors on animals, ships, 17 ships, 10 aircraft. You maybe heard about the hurricane hunters that go fly through hurricanes, several numerical models for weather forecasting and other purposes, and also extramurally funded data, which is going to be of relevance to people from the university community especially. And so these data are unique, valuable, irreplaceable. You can't go back and remeasure something when the time has gone by, at least not in the same conditions, and collected at public expense. So we want to make sure that taxpayers, businesses, anybody who wants the data can get to the data because they've essentially already paid for the collection. And this graphic here, also from the NOAA 101 briefing, shows that our scope is from the bottom of the ocean to the surface of the sun, because we really do, we measure bathymetry, water conditions, the atmosphere, and space weather conditions, solar flares heading towards Earth, that kind of thing. So tremendous variety of data. And my vision, and the vision of many others, is that all of our data should be discoverable, accessible, usable, and preserved so that people now and in the future can get to the data. And basically all my work is involves focusing on kind of how we do these things and how we improve it. And we're doing actually pretty well, but there are some data sets that are not really up to snuff. Fortunately, this vision is shared not just by me and others at NOAA, but also by the White House. So there were a couple of initiatives that came out in 2013 which were of great relevance and that we really welcomed. I don't know if you've heard of them. One was a memo from the White House Office of Science and Technology Policy, authored by Dr. John Holdren, on public access to research results, saying, hey, we have to have open access to research data, to scholarly papers based on those data, to grant data and intramural data, and we need to be citing the data used in publications. So that came out in February 2013, and then a few months later, there was an executive order and an Office of Management and Budget memorandum called the Open Data Policy, also talking about open access for research data, as well as non-research data like business data, other kinds of things that the university does. And then also being somewhat specific about things like metadata, cataloging, having an agency inventory of all your data, making data be online through machine-readable services, using standard formats, that kind of thing. So this was great because it gave us kind of high-level backing for some of the things we were pushing for, and has really kind of catalyzed a lot of activity at the agency. So that public access to research results memo in particular said every agency that has at least $100 million in research funding has to write a plan for how they're going to do all the things in the memo. So we did write a plan. You can get to it at the URL above. There's a little screenshot of the front page. It came out in February 2015, so that's 2 years after the memo. So there was a lot of back and forth where the White House was looking at agency plans and trying to get things aligned with each other and so forth. But in short, I mean, it's a longish document, but it basically states that we're going to develop or continue or revise policies and methods for public access to data and scholarly papers, whether they're intramural or extramural. So a lot of things I'm going to tell you now are kind of things that we're saying we're going to do in the plan. So data preservation and stewardship. We have this thing called NCEI, National Centers for Environmental Information, which is the new name for what used to be the National Climatic Data Center, Geophysical Data Center, Oceanographic Data Center, sorry I missed an O on that one, and the National Coastal Digital Data Development Center. Maybe I got that acronym wrong. National Coastal Data Development Center. I think that's what it really is. Okay. So basically these 4 centers plus some other smaller facilities. And these are our sort of premier world-class data preservation facilities. And they're really focused on long-term preservation. It's not just data on a disk somewhere that you have a backup copy of. It is long-term, 50-year, century-long preservation. We actually have to go through a process if we want to get rid of something, public comment period, to make sure nobody minds if we do that. But basically, anything that's an observation that goes in there, we keep essentially forever, because you never know when it's going to be useful to have some of that old data. Currently has about 20 petabytes of data, which is a goodly sum. Some of it, not all, is on online disks. That's great. You can get immediate access. Others, like the NextRad radar data I'm going to talk about, are on nearline tape. So you have to ask for it, and then the machine goes and gets it, and it could take hours, a day to get it back. So that's going to be a problem. And there's actually a basement full of paper records, so not everything is digital yet. But anyway, that's our archive facility, and I'll mention that again because that's going to be a great place to send at least some grantee data if we can do that. The URL is down there at ncei.noaa.gov. So we're also doing lifecycle data management planning. That was one of the things called for in the PAR memo from the OSTP. This link here, nos.noaa.gov, EDMC, is for the committee that I'm currently the chair of. The committee's been around for a while. In fact, we have this NOAA Administrative Order on Management of Environmental Data and Information, which came out in '91. So we've long been saying you've got to manage your data well, you've got to make it accessible. And then it got revised in 2010, and it gave authority to the committee to issue policy directives. Procedural directives is the technical term, and we've been working on some of those, and I'll tell you about those. We also came out with this document called the NOAA Environmental Data Management Framework, and that little graphic in the upper right is sort of a sketch which laid out for all data sets sort of basic principles, governance at NOAA, resources, standards, architecture, and assessment, and then talks about a data life cycle and what you have to do at each point of that. So it's like a 25-page document, which is sort of the manifesto, if you will, about what we're supposed to do. It's not a policy; it's really just a white paper, really. But it's good. I think it lays out things pretty clearly. And then we came out with a data management planning directive. It was already out in 2011, but we revised it after the memos come out. You can get it at the URL above. And in short, it says all NOAA observing systems must be covered by a data management plan. And in theory, they all were supposed to either have one by January 1st of this year, or at least a list of the ones they don't have a plan for yet, and sort of a timeline. In reality, they don't all have one, so we're starting a new assessment this year. This is kind of a graph, got a little bit cut off, but of sort of the number of data management plans received from each NOAA office, and it shouldn't be zero, typically. Some of them have many more data sets. We're trying to actually figure out how do we make it fair so that like one office really only needs 2 plans, ships and aircraft. Others need 500 plans, and so how do we make all the offices look good if they've done all their work, ranked by percentage or something. But anyway, we're going to begin a second assessment this year and put it on our NOAA Data Management Dashboard, which is an internal website we're working on. So data management plan, definitely something we're doing. The PAR memo said, no, the open data policy said every agency has to have an inventory of all their data. And they actually proposed a not very good method for the inventory. They said, send us a single file in JSON, JavaScript object notation format, which lists every one of your data sets with some information about each one. So NOAA, though, has, as you can see here, about 65,000 data sets, actually more, because not everything is yet in this catalog. And that file, which we do produce, is huge and unwieldy and not really usable by anybody. So instead, we installed a catalog. This is a piece of software called CCAN. You may have heard of it. It's open source software. We're currently running it on the Amazon Federal GeoCloud. And there we list all of the data sets we have. So you can come here, data.noaa.gov, and you can start finding data. We've got some improvements planned. I think it's not as good as it could be, but it's there, and everything we know about is registered. We are trying to go farther, though, than just this human user interface. We have a little bit of a bigger vision. So if you envision the catalog here in the middle, the idea is you should be able to find all of our data by the location of interest, the time of measurement, the phenomenon, other characteristics, and not have to know about how NOAA is organized. Traditionally, people have to know who the principal investigator is or know which line office produced the data. This should be allow you to search across all those things without knowing the internals of NOAA. And we are building it. This is now working. We're basically harvesting every week from local catalogs and WAFs. It stands for Web Accessible Folders, which are basically online web folders where we put in metadata records, typically in the ISO format, sometimes in an older FGDC format. And so every one of these data sources, in theory, should have metadata records about its holdings, and we read that up. And then we recently got working, after some effort, a standard query interface called a catalog service for the web to expose the holdings outside. And finally, data.gov, which is a US level inventory of, in theory, all federal data, is able to read our holdings as well and populate itself. So the idea here is, if, let's say, you operate a satellite, if you do the right thing and put the data somewhere with a metadata record and we know about it, then it will automatically kind of float up and be visible in data.gov. We're just starting to look at geo now and improving how we talk to the International Group on Earth Observations. Not really yet working explicitly with these other client tools, but that's part of the vision. So we are trying to make it so that if you're a data owner, you do the right thing at kind of your level and it floats up and you don't get asked, like we used to get asked, please register your stuff manually in data.gov or the GCMD Global Change Master Directory. We're getting a lot of those kind of requests before. So that's kind of the vision of that catalog, and I think we're doing pretty well on that. Not quite done yet, but. So metadata is really the foundation for this. We have a policy, the Data Documentation Directive, that says we should be using the ISO metadata standard, ISO 19115-2, and some related ones. I won't go into detail about what that is unless you have some questions, but that's kind of the key thing for geographic metadata. We also have some software that assesses, are these metadata records complete, what's missing from them. And this is a graph showing the top of the graph, the total is the number of metadata records we've been assessing as a function of time, starting in, looks like 2013, going until now. So we kind of look at this about monthly. And then showing the ones that are good, that's blue, less good, green, kind of crummy, yellow, invalid, or not ISO. So there's a small fraction that are actually not ISO. They use the US Federal Geographic Data Committee standard, but most of them are in ISO and are getting good, getting better, and we're kind of working on these improvements. So now if you want to get something into the catalog, for example, we run this rubric on it, and we see if it's good enough, and if it's not, we have you fix it, and then we put it in the catalog. Open standards and machine-readable formats. So I've long been a proponent of that, but now the White House is saying we should be doing that. So we've been working especially with standards from the OGC, the Open Geospatial Consortium. I'm the NOAA rep to that, but if you haven't heard of it, it's about maybe 400 organizations around the world, governments, private companies, universities, software developers to some extent. Well, a lot of software developers, commercial software developers like GIS software, members of this, trying to agree on some standards and then implement them in their products or on their data holdings. So I just want to mention a few projects. We have this thing called the Unified Access Framework, which is using Threads data servers and climate and forecast conventions with NetCDF data. This is actually the kind of nerdiest slide, I think, on this. Sorry about all the acronyms. But, you can get to it at this geo-ide.noaa.gov. And what it's trying to do is bring together all of our servers that have gridded data, so especially numerical model outputs or other gridded data, in kind of one master threads catalog, TDS, and it just points to the other servers. And along the way, they fix up some of the metadata, they make improvements, and so forth. So that's been a good project. A somewhat more recent development is the NetCDF feature type template. So we were using NetCDF for gridded data, but some of our data is not gridded data. We have in situ data. You measure something off the side of a ship or something like that, or you have a buoy, and you can encode that in NetCDF, but it wasn't really well defined how to do that. So we've developed, as part of our archival processes, these feature type templates which standardize how you would use NetCDF for this type of data, and that's what the archive is now accepting. So that's been a good thing. And then I want to mention IUSE, just because I used to work there, Integrated Ocean Observing System, and we spent some time establishing things like OGC sensor observation service for our buoys and water level monitoring stations. And there's a screenshot there of the IUSE website, and the GeoIDE Unified Access Framework page. So these aren't the only examples, but these are some that I've been kind of involved with and interested in. We also have data which is not in an open standard, maybe it's a let's call it an intergovernmental standard that was worked on 20 years ago, and which we haven't been able to change because now this is operational data exchange between weather agencies, and now we're starting to think about how do we modernize some of these old standards, even though we're using them operationally. All right, data citation. This is a big thing that we've been interested. We started a few years ago a data set identifier project, where we're issuing digital object identifiers. Some of you are from the library, maybe you've heard of DOIs. We're trying to assign them to data sets in our archive. and we came out with a directive on data citation. It doesn't say you must get an identifier, but it says what you have to do if you want one. And basically the key requirements are you must archive your data at NCEI for a NOAA DOI, and you must have a good metadata record, because we actually use the metadata record to automatically make a landing page about the data. And this is a graph here showing a number of DOIs issued since we started in 2013. It's going up and up and up, as you can see. Right now, we're still assigning these manually. So kind of one by one, we look at a data set, make sure everything's good, and send it. In theory, we could work with EasyID, which is a University of California thing that we have a license with, to automatically assign DOIs. We haven't gone there yet because we'd rather not accidentally assign one and realize we didn't want it, because we do consider them permanent. And that permanence, in fact, is why we're requiring archiving before you do it. And then looks like I'm mentioning ESIP here. That's the Earth Science Information Partnership Federation, great group that NOAA helps to sponsor, and NOAA and NASA as well. And it brings together a lot of people working with earth science data, developers, users, producers of data. It's an excellent community with a couple of meetings per year. And they, among other things, issued some guidelines on data citation, and we adopted a lot of those in our directive, so mentioning them here. In case you're not familiar, this cartoon kind of shows what we're trying to do. So let's say you have data and metadata. We want you to submit it to NCEI for archiving, and then we're going to assign you this digital object identifier, which is a URL that will never change. And if you follow that URL, it will get you to kind of the current location of the data, or more specifically, a landing page, a human-readable text description with links to the data and the metadata. And if we move that landing page, we can just update the URL, the DOI database, but the ID will stay the same. And then if you write a paper using the data, well, you can cite the paper using the DOI, just like you would cite another paper in your research. And many papers now also have DOIs. So there's this big movement now to be assigning DOIs to data with a group called DataCite at datasite.org, which is kind of championing that. And we've been following along, so I think that's been very good. We've been counting how many DOIs we've assigned. We haven't yet started seeing whether anybody is citing those DOIs, but I think we can start doing that now, basically, because they've been out for a couple of years. All right, making data public by default. So that was a key thing. And we already had verbiage about this, but we went further last year and issued a data access directive, which was very explicit, saying you must register your data, your NOAA data. By the way, these policies are for NOAA people. I haven't gotten to the grantee policy yet. You must register your NOAA data in our catalog, and you must make it accessible online, preferably via a standardized service. And if you don't want to do that, if you have a legitimate reason for not doing it, then you can get a waiver signed at a very high level, at the kind of associate administrator level of your part of NOAA. So it used to be people would say, well, I think my data, it's got some, I'm still working on it, or I've got some, it shows a shipwreck, so I can't make it public, or maybe there's some personally identifiable information. So people would decide for themselves that they couldn't share the data. Now we're saying you have to prove to somebody, or at least justify to somebody, that you really are allowed to not share it and get this waiver. So, and we're trying to use a service-based approach, as kind of illustrated in this cartoon. I'm not going to go through it in detail, but then we also have this thing called the NOAA Big Data Project. So that's new. That is an addition to making our data public, and I wanted to tell you about that because I think it's exciting and possibly game-changing. What's happening is we have an accelerating demand for user data. We see. This is a graph. It ends actually in 2014, but it's actually gone higher than that now, showing the number of petabytes of data delivered of various types from our archive. It doesn't even count data that didn't come out of the archive that somebody got from another source. So more and more data are getting sent out. That poses a significant load on our infrastructure. And also, and maybe more importantly, it's hard to get all of the data, or very large data sets, because some of them are stored on tape, as I was mentioning, and it takes a long time to get them back out. And so we started this thing called the Big Data Project. The premise was we've got large and diverse data sets, they're hard to get, and even if you get them, you now need the infrastructure at your own location to hold on to them and work with them. And so as a result, the data are underutilized, especially by people who are not experts, because it's so hard to get to them. And yet, we think that there's economic value in the data. We already saw that by releasing weather data, we created new industries, right? The weather company and all these TV stations, everything, doing weather forecasts. That's due to the release of NOAA data, even though, sometimes people might think, why do we need NOAA? We have the Weather Channel. That's where I get my weather. They don't realize it comes from NOAA in the way. And so we sometimes have to remake that clear. But fundamentally, there's NOAA data involved. Or another example, not NOAA, is the GPS data, right? When the GPS signal was unencrypted so that you could get high resolution, this whole industry, the spatial data industry, came up, and now you can navigate wherever you want on your phone, and that's great. That's because we made data more readily accessible, and it's generated these big industries. So the question for us is, what other value is hidden in our data that we can't get out because people just haven't really had the opportunity to try that easily? So we think that we can get more data out, but more value, out of the data by staging it in the cloud, where people, organizations of all kinds can actually work on kind of a market basis, try things in our data, see if value-added products can be made. And I just want to have a little brief definition of what I mean by cloud here. I'm really talking about shared computing resources that are available on demand, that are scalable so that you can request more of them as you need to, including things like storage, memory, CPU for computing, other services on top of that. So you've heard the cloud, you probably already use the cloud, right? Anytime you're using Facebook or Gmail or something like that. We're talking about using it specifically as a place to put data so people can come to compute on the data. Instead of downloading the data yourself, you just go there and do your computation right on the data. In fact, this next cartoon is kind of a architectural overview of what we're trying to do. I want to stress here, are keeping the master copy of our data. We're not just sending our data out and then not ever keeping a copy in case one of these companies decides to go out of business or something like that. But so we've got the master copy of Earth observations and model outputs. And we are still running agency services like the catalog I mentioned, online access, still trying to have good metadata and formats. These are still happening, and we're not turning these off. I'm stressing that because some people fear, we're going to do this cloud thing, and there will no longer be public access, and that's not true. So we're trying to do these services. But the premise is, can we push data outside of our own security boundary, push a copy of the data, or at least some of the data, to the cloud, to cloud infrastructure as a service providers, IaaS, and so that we or others can actually put kind of computing functions on the cloud for data integration, data analysis, that would let you make customized products or applications from the data. Customized for new customers, maybe new lines of business even, like I was just talking about. Or not even necessarily customized, it could be sort of broad scale, but new in the sense that we hadn't done these analyses before because it was hard to do that. And we think there could be a market here. So our data are free, and we're not permitting the cloud providers to sell our data, but we are permitting the cloud providers to sell computing time to somebody who wants to run an application on the cloud. And if somebody runs an application on the cloud, and creates something new, a value-added product, they would be, if they wanted, be permitted to sell that value-added product to some external customers. So there could be some economic activity going on here. And NOAA is part of the Department of Commerce, so the Secretary of Commerce actually is the one who announced this publicly once we got it going as an activity. So we're seeing where that goes. It's still a little bit new. The concept is, what we actually ended up doing was, we couldn't choose just one provider, and we realized, is there something? No, here we go. Okay, I thought I was missing a slide there. We ended up signing research and development agreements with 5, Amazon, Google, IBM, Microsoft, and Open Commons Consortium, formerly known as Open Cloud Consortium. OCC is an academic entity out of University of Chicago. These other 4, you've probably heard of them, are commercial cloud vendors. So we have these 5 R&D agreements, and then they in turn work with partners who are interested in using the data, because these companies, they're experts in the infrastructure of the cloud. They're not necessarily experts in environmental data and science and so forth, but they can work with partners like the Climate Corporation or Esri software company or others to actually use the data, extract value from it, and so forth. So we've got our data. This currently is keeping our services, but sending, in theory, up to 5 copies of any data set desired to these clouds. It took a while to set this up. We had a public request for information, an RFI, in 2014, asking industry should we do this? Does it sound like a good idea? And we got very good, very enthusiastic response. Actually, somewhat enthusiastic and yet tempered. Many of them said, yes, please do this. Start doing it now. But we're a little concerned because you have a lot of data. We're not sure we can really take all of your data for free. How are we going to actually make this happen in a way that's not risky to us as a business? So that's why we're treating these as R&D. We have these agreements where, if needed, they can give us funds for cost recovery, but we are not funding any of these cloud companies for the work they're doing. But we got about 70 responses. Some of them really good, very much on point. Others, trying to sell us tape drives or sending in resumes. But overall, seriously, but some of them were really, really good responses. People who had really thought about this and understood environmental data and so forth. Then we had an industry day. We had about 200 companies in our NOAA auditorium here, and again, asking us to move forward. So we signed these R&D agreements. In the RFI, among the questions we asked were, if we do this, what data do you want to see? And these were probably the top 4 data sets that were requested. One is weather radar data, which I'll talk to you about more in a second. Another is the multi-radar, multi-sensor product, which actually is an enhancement from the more raw weather data into a new kind of gridded product. Geostationary satellite data of great interest, especially the one we're going to launch called GOES-R next year. And then numerical models. Numerical models were probably the top interest, but they're actually the hardest one to do, because we run these weather models and we send out forecasts. I mean, I'm sure you've all seen a weather forecast, and behind that are these time steps of data showing the conditions every so often as forecasted by the model. Well, we only send out about 1/10 of the time steps that we compute. We just don't have the bandwidth really to send them out. So these are kind of intermediate products that get lost. And yet the weather industry is saying, we want to see all of the data. We want to see the finest possible resolution you can give us. So now we're starting to think about, how do we make that happen? How do we give these companies a pipe directly into our supercomputers somehow in a way that's safe for us and doesn't slow down the weather forecast, but lets them get these fine-grained time steps. So we're still trying to figure out how to do this without impacting our operations. But we started then with the weather radar data. So NextRad is the next generation radar. You might have seen stations like that dome there in the lower left. You see them at airports. Or you've seen these Doppler images that show rainfall. This is from, I guess, a year ago or something like that, a few months ago, showing rainfall or precipitation across the U.S. So the data exist, and they are publicly accessible, but it was very hard to get to them. The total volume is about 270 terabytes, and we worked for a while with a guy who founded the Weather Underground. Don't know if you've heard of that website, Alan Sternberg. He was one of the people who was on a 1-year Presidential Innovation Fellowship working with NOAA to kind of get this project off the ground. He had tried to get the NextRad data, all of it, for his project, and it was taking him more than 1 day to get 1 day's worth of data. So he realized, he was never really going to be able to catch up. So now he doesn't have to do that anymore, because we sent it all to Amazon, as well as to Google and Microsoft. So at this URL here, you could actually go to Amazon's copy of our data. They're serving all of it from 1991, when the first radar came in, to 5 minutes ago. They got everything out of the archive and established a real-time feed using something called Unidata IDD LDM, Internet Data Distribution / Local Data Manager, piece of software that people use to distribute data around. So they've got an IDD LDM feed, and they're getting all of the data. And so now there's a single point of access for real-time and archive data. In the same way, the real-time stuff comes, and then within a few minutes it's moved over to the quote archive section, and it looks it gets sort of repackaged, and then it gets moved over. So you've got this kind of identical set of data all here, and you can go and compute on it. You can actually download it for free. So Amazon is storing it for free for us. Also offering free data download. So if you wanted to go, you can get the data. You don't have to pay egress charges, which normally apply for Amazon Web Services. But you would have to pay if you want to compute on the data in place. I still think that's a better idea, though, because do you have 270 terabytes of data of storage sitting around? Do you really want to wait for it all to come there? Why bother? You could just go there and compute right there. You can pay pennies an hour, up to maybe $5 an hour, depending on how fast you want to compute, whether you need something right now as fast as possible, or whether you're going to wait until midnight tonight when things are a little more quiet. So it's possible to work on the data directly. Right there. And I think if people don't start doing that, this project, I think, will not be successful if the only thing they do is download it from them instead of us. So Amazon made their public announcement in October of last year, the 27th. Google and Microsoft and OCC have not yet made a public announcement. In fact, we're wondering, are they cooking up something? But Google and Microsoft did get all of it. OCC is a smaller thing, so they've gotten basically the last year of data and then the real-time feed, and they're working on that. But there it is. So now we're starting to tell users about this. If you come to our archive page, in addition to the links that would have previously let you get to the data, to our copy of the data, those are still there, but we're also linking to the Amazon entry point and to the other ones as soon as they make it publicly accessible. And we've integrated this into a piece of software called the NOAA Weather and Climate Toolkit. Here's a screenshot of it, so it lets you basically see weather data, and then if you pop up the window in the upper right that lets you choose from various sources, Amazon is now one of the options for getting files out and showing them. And again, we would add the other companies as it came up. All right, so that was the big data project. I want to go back now for a second to these data management directives. I already told you about some of these: data management planning, data access, data citation, archive approval, we have one, and then metadata. But the newest one, which we've just issued and revised, it was effective March 1st, is on grantee data sharing. And I want to spend a little bit more time on that since you're from a university and maybe grantees. In short, it says grantees must share data in a timely fashion. That's the kind of the key part. The goals are that environmental data produced with NOAA funding are made publicly accessible in a timely fashion, as I said. What timely means is within one of the following, whichever is shorter: within 2 years of the end of the grant, or within 2 years of the end of data collection, or upon first publication of a paper based on the data, which might be less than 2 years. So whichever is shorter than that period, that's kind of what it is. So it's trying to get people not to hang on to their data forever and kind of milk it for every paper it's worth before making it publicly accessible, because they're more valuable usually if they're more timely. And that provision was already in the original version of this directive, but we've made it kind of more clear now what timely means here. Totally new is manuscripts of papers. So you write a paper based on data, you submit it to the journal, you get back your referee reports, you revise it, finally it's fully accepted, you send in your final manuscript for publication. We want to get a copy of that manuscript, and we'll put it in our NOAA library in what's called the institutional repository, and we'll list it in a kind of table of contents and point people for the first year to the version of record, the journal's published version of the paper. But then after 1 year, this 1 year embargo, that was the White House's choice, we make the manuscript visible publicly. We still point to the version of record at the journal, but we will make that manuscript visible so that somebody can actually read the science without needing a subscription to the journal. So this was a little bit contentious with the publishers, of course, whose whole business model is selling subscriptions, but it's happening, and we're going forward with that. So we would ask grantees then to just submit this manuscript either as soon as they're done with it and send it to the journal, or certainly by the time of publication. We also ask that you cite the conclusions, cite the data used to support your conclusions using DOIs if we have them, and also to acknowledge funding sources in a standardized fashion. There's this newish thing called FundRef. You go to submit your paper, and among the things it asks you on the web form are who funded your paper, and you can kind of choose with known names of institutions. So this kind of supplements the usual paragraph, thank you very much to NOAA grant number so-and-so for funding me. Now you can actually choose NOAA in this program. And so then we can actually go and query and see, which papers were written using my program's funding. So it's kind of standardized metadata about funding. This little cartoon kind of shows you more what we're trying to do. So the full title is the Data and Publication Sharing Directive for NOAA Grants, Cooperative Agreements, and Contracts. Kind of long. It will in a second. Sorry, it's animated. So the actors in this cartoon are NOAA, of course, and then researchers. And the idea is we're going to issue federal funding opportunities or contract solicitations, and they're supposed to include data management guidance, suggesting how we think you should manage the data if you receive the funding. And then if you want to respond to that, you write a proposal as usual, and we want you to include a data management plan in the proposal. The earlier version of this from a few years ago just said, include a data sharing plan, up to 2 pages, and it really gave no guidance as to what to put in here. So now we're going to give you some guidance and what we think should be done, and then you can respond and confirm you're going to do that or propose something better maybe. But anything other than I never want to share my data, that is good. So if you get funded, that's great. We'll send you some dollars, and meanwhile you're going to go and collect the data and write some papers, hopefully. That's all as usual. But new thing then is make that data accessible somehow, and I'll show you on the next slide some of the ways we're suggesting that could happen. Also, as I said, cite the data used in your paper with a DOI if available, and then cite the funding with FundRef, and last click here, and then deposit the manuscript at NOAA in the institutional repository, where, as I said, we'll expose it after an embargo. And the institutional repository, by the way, was supposed to be online in January, and there's been some delays, but I got emailed just minutes before this talk saying it should be online today. So that's good. Maybe I'll give you out the URL in case you want to. There's probably nothing there yet, right? But anyways, we'll make sure that that's visible and you know where to send that. So that cartoon is kind of showing the outlines of what we're trying to make you do, or what we would love for you to do for us. So what are some of the options that we've offered? In our data management guidance, you might see one or more of these things. I think the best option, if it's feasible, is submitting data to NCEI because it's preserved, it will be made accessible, it will show up in our catalog, you never have to worry about it again. You can still serve it from your own web server, whatever you want to do, but there's a nice copy kept forever for you. So that's ideal. But that's not always possible. It might be you might have data of a type that's not relevant to NOAA, or that's too big or too unusual and we can't take it, or we could, but it would cost money. So that's not always the only option. The grant program could tell you, hey, submit it to this other NOAA facility. We ask all our grantees put data here, so it's not NCEI, but it's another NOAA facility, and we'll tell you which one it is. Or submit it to another system somewhere else on the planet, in the International Council of Science World Data System. NCEI is part of the World Data System, but there are other facilities, and some communities use these traditionally and have for years or decades, and so it would make sense to continue putting the data there. Too far there. Or this, I think, is going to be increasingly popular. Send it to a public data repository. So these are starting to crop up: Dryad, Figshare, Dataverse, and others. And some communities are using them, so it would be reasonable to keep putting the relevant data in those communities. And they have some level of archiving and guarantee of service, so that's good. Or maybe you already have a server. Maybe your university already has a server where you host data for your grantees. That might be an appropriate thing. The hardest one, I think, is establish your own data hosting capability. Okay, I'm going to go buy a computer. I'm going to turn on all these web services. I'm going to have a system administrator. I'm going to run it. It's doable, and maybe it's the right choice, especially if you have high volume data that you don't really want to ship around. But that's you don't want to be explaining in your proposal how you're going to do that and why you want to do that. Or finally, you could, if you needed to, request permission not to make data publicly accessible with a good reason. For example, you're studying shipwrecks, and we don't want to reveal the location of the shipwreck so people don't go plunder it. Or you're doing human subject things, and you can't make the original data publicly accessible. But so those are some of the accessibility options we're going to be recommending. All right, now moving away from the grantee thing, I want to make sure I mention this interagency activity which just came out, or document that came out. It's from the U.S. Group on Earth Observations, and it's called the Common Framework for Earth Observations. So USGO is an interagency group. Some of the agency logos are shown here in the upper left. And it's a subcommittee of the Committee on Environment, Natural Resources, and Sustainability of the National Science and Technology Council, which is part of the White House Office of Science and Technology Policy. And within the USGO, there's a working group, Data Management Working Group, which is co-chaired by NOAA, me, and then a NASA person and a USGS person, with EPA, USDA, and other agencies involved, National Science Foundation. And so together, we put together this common framework document. It just got released last March, just ahead of the president's trip to Argentina, because one of the things that was on the agenda was cooperation on hydrological and meteorological data. And they were saying, hey, this is kind of what the government is going to be trying to do. Are you interested in doing the same thing? So it just went out. You can get to it at this short URL there at the Google URL shortener, which will lead you to this much longer and horrible URL on the White House site. But it will take you to this the PDF document. And what that says is, look, we want to try to make data searchable, make it discoverable. We want to have access services and good data documentation, compatible formats. What are we recommending to do those things? Because we've seen a lot of documents that are statements of principles only. Thou shalt make thy data discoverable, but it doesn't actually say how to do that. So here we're saying, no, we recommend this particular standard or this particular approach to make the data discoverable, accessible, whatever. And what we're recommending are open standards. We're not recommending pieces of software, especially proprietary software, although we even mention some pieces of software. So this is not government endorsement of somebody's software, but it is government endorsement of specific standard approaches. And the idea is if we have these shared standards, then data can more easily flow from the data sources from these various agencies at the bottom of the screen up to the user tools that people use, data.gov, decision support software, whatever it is, even value-added providers. So, what are some of the shared standards we recommend? These are not requirements on the agencies, and they're not requirements on the grantees. They're just recommendations that we feel, if followed, could improve the situation. All right, so what are some of the challenges here, at least on the NOAA side? There are a few. I think one is awareness. So we got the committee toiling away, writing these directives and sending them out. But NOAA has 10,000, 12,000 people, something like that. How do they find out about this stuff? There's this whole outreach activity that has to happen, which is not very easy. We try to do it. We have an annual data management workshop for NOAA people. Get about 150 people there, but not everybody knows about it. It's sort of the same club of people who are active in this area who are there. So trying to get the awareness out is important. And once they're aware, are people willing? This could be extra work for people, right? And why should they do it? They know how to read their data. They don't need any metadata. It's on their hard drive. Why should they make it accessible for somebody else, right? So there's, people are not necessarily willing. How do we measure if they've done stuff? Metrics. We're kind of working on that. What I want to see is kind of automated metrics. Maybe we go through our catalog and see how many of the data sets listed here are actually accessible online, how many of the online access points are standard services, what's the metadata score? Well, I showed you the graph showing the metadata score, so we have that. So kind of automating some of the metrics gathering on this. And how do we know if we're close to 100%? If somebody doesn't register their observing system in the catalog, unless it's one of the big ones that kind of show up in the overall budget, it's hard to know that somebody's actually gathering data. Sometimes they can kind of hide anonymously. So how do we really know if we're almost done? And then finally, what are the resources? How do we keep this up? Well, I finally, after 2 years, was able to get a contractor to help work on the catalog and make some needed improvements. The data owners also need some funding. We actually got a little bit of funding last year, and we were able to issue 14 sort of mini grants to NOAA people, and we're hoping to do that again. But that just addresses 14 collections of data, and it doesn't get to the whole vastness. So where are the resources for that? That's tough, but we're still working little by little, and I do think we're making progress. So in summary, NOAA, I think, has long had an ethos of open data. We've always wanted our data to be open, but it was encouraging to get guidance from the White House to kind of give us that backing. So we're refining the policies and practices and starting to try to track how that's going to happen. New requirements for grantees, I'm sorry about that. We will try to make them as easy as possible. The cloud computing thing, I think, is going to be very promising for large data sets, but we'll see how these R&D agreements play out over the next 2-3 years. And then finally, other agencies with Earth observations are working with us toward these common approaches. So thank you very much for your time. I think we do have some time for questions, right? Yes, please.
So, just curious, your publishing model is all investigator-driven and not publisher-driven.
Mm-hmm.
Given NLM and NIH's success with PubMed Central and the willingness of the publisher to actually do publisher-based depositions of the article, why not follow that path?
So have the publisher put the manuscript with. So we're not opposed to that. In fact, our original version of the the plan said, oh, we'll just use Chorus, the Clearinghouse of Open Research of the United States, which is something that publishers have signed up to do. And they said, oh, well, sure, we'll make data sets visible, or I'm sorry, publications visible through that. And we were basically told, we don't want you to rely on that. You need to set up something so that you get the manuscripts. So if it turns out, it would be great if the publishers, upon receipt of the manuscript, would also just send a copy to us. And if we can make that happen, that's great. But we were still told by the White House, you need to try to collect them and make sure they get there yourself. So.
I will say, I'm now Mark, I'm from Hardin Libraries on Sciences, and I will say that even though, some publishers do that, many do not
Mm-hmm.
with NIH, and even many of the publishers who have said they will, they think they have that whole year embargo to get it into the system, and they don't. You're only supposed to get into the system and appear as a citation in the first year.
Right.
And so I think publishers don't need a lot of education, so I think that it's not a bad thing that you're not spending on the.
Right, right. And I can understand the publisher's angst, right? And if they felt like, well, all we have to do is kind of wait out the current administration, maybe this will go away like a bad dream. So, I understand their reticence. So.
I would think that most libraries are not canceling subscriptions because something is available in PubMed Central, because our researchers need that stuff now.
Sure.
not in a year.
Absolutely, absolutely. Yes, please. It's just an act. Yes, I would, and I'm not saying that to brag, but we've kind of been told we are. NOAA, NASA also. I think because we have these big, expensive, automated observing systems like satellites, you have to build the machinery just to kind of do the right thing with the data from the start. So that helps us have this history and a lot of thinking about how to do it right. So I think we are ahead of the game. The challenge really is in a lot of the smaller, the high variety data sets rather than the big ones. And the model outputs. That's also another kind of challenge, which they're huge, but yeah. So, but we are ahead of the game, and we've kind of been told that we are. So that's great. Yeah, some do. Yeah, we talk with other agencies, or we're having a series of interagency meetings talking about the PAR and what the agencies are doing. So that's another forum where we talk about that. That includes all agencies, not just Earth observation, but NIH and others. In fact, NIH just last week gave a little briefing on a cloud project they're doing, setting up a place where grantees could put data, which was just awesome, with some good funding behind it and so forth. So or I guess potential funding behind it. I was very glad to hear about that. I think it was affiliated with that. There was some other name for what they were doing. Data Commons, yes, I think that was it. Yeah, so that was great, and they had some really good ideas, like credits for. Well, I don't even know how much of this I can say. It was a great talk. Yeah, wait for the announcement. I don't know how much is public.
Was that still boring?
It was not. No, somebody else. Yes.
I was just wondering if these recent updates and changes, if you could cost neutral to the organization, or there's been new money or money shifted into doing that?
Yeah, I think it's not entirely cost neutral. We did get a little bit of money to make some of these improvements. If we're going to undertake a campaign to bring every single data set up to snuff now, it would cost a lot of money. And we're not asking for that. But what we are saying is, look, if you're going to build a new observing system, can you do things right from the start? Or if you're going to do an upgrade of your system, could you please make these improvements as we go? So I think it's going to be gradual. We've actually sort of exempted, old legacy data sets that don't really belong to anybody anymore. Okay, you could get away with not doing anything. But, if you're still getting funding for running your observing system, we'd like you to kind of get on the ball. And at minimum, write the data management plan that tells us what you are doing, even if it's not perfect, just so you start thinking about these things. But yeah, there is funding. I think in the end, we will save money by doing things right. Because right now, all these different formats and ways of getting data, spend a lot of human time and software development time just accounting for all that. So long term, I think it's a money saver. Short term, maybe not. Yes, please. Well, sorry, you and then you. Oh, okay. Hmm. Yes. Did I probably deleted? That's too bad. I had some. I had a backup slide which I deleted, which showed the data lifecycle. Let me just kind of go back to this one for a second. As a just kind of illustrator. So I think you're talking about the EDM framework that we wrote. Okay, right. So yeah, I think that's a pretty good document. It talks about some of these cross-cutting things, like the principles, why we should share data and so forth, and what the committees are at NOAA that does it. But then it does elaborate on a data life cycle, which it divides into three things: the activities you do before your observing system is running, the planning and so forth, and then the actual management of the data from the system, acquisition, processing, adding metadata, archiving, making accessible, and then things that users might do that you have no control over necessarily. And it kind of identifies some of the feedback loops between some of those processes. In our data management planning, we have a template. So the NOAA Data Management Planning Directive for, let me stress, NOAA observing systems, not grantees, you don't have to fill out this thing, asks you a bunch of detail, like, okay, who's responsible for this system? How do you make the data accessible? Are you archiving? If so, where? If not, why not? How are you writing metadata? What metadata format are you using? So forth. So it kind of goes into the detail about that. It's actually a pretty nice template, which I think addresses a lot of the key points in the life cycle. Yeah. How do we decide to dispose of the data? Well, generally we don't. Okay, if it gets to our archive, and it's an observation, we don't get rid of it. There is a procedure that can be followed to get rid of data, which includes a public comment period. So we will tell the world, hey, we're planning to delete this data set. In reality, as far as I know, we have never deleted any observations from the archive. It actually costs more to delete the observations, including the public comment period and actually finding and getting stuff off this, than it does just to keep it on disk. You know, storage is cheap, so we haven't deleted anything. So, yes. Oh, yeah, okay.
Assuming that we're in a field that's outside of NOAA's umbrella, like
Yep.
vegetation research, for example, is where I'm at, are there any other big federal repositories, or do you have any tips for kind of on a small community of researchers starting their own kind of open data?
Yeah. So honestly, I don't know if there are other repositories. I would like to think that there were, and if so, I'd suggest search first and don't build your own if you can avoid it, because maintaining all that is a big hassle. And then if you are going to build one, build it on the cloud. So it's like so many other companies and entities have done, so you don't have to maintain all those machines. Some of the other agencies with non-environmental data are certainly involved in these interagency meetings. Unfortunately, I don't have a good, kind of point of contact to send you to, but I could look for one and send it to Sarah, who could pass it on. Talk to your librarian. You're right, Sarah. Sarah is hereby your point of contact for the. Okay, and you had your hand up too. Yeah, I think the librarian role can be an interesting one with the data and the publications, right? Just making sure people understand the requirements, making them aware of some of the options, maybe helping write, I don't know if this is a stretch, but helping write a good data management plan for your grant. Some of that might require, other types of expertise as well, depending on the data. But making sure people are aware of the requirements and are responding in some appropriate way, I think, would be a very good role for the library. And also helping to check that researchers at the institution have done these things, right? Because when we give a grant to somebody, ultimately it's the kind of the institution that's responsible. So if things are falling through the cracks somewhere at a university, it would be good for the university to know about it and maybe lean on their researchers. So I think the library could have a very big role there. Yep. The metadata role. Okay, so yeah, if you want to, well, it depends on the metadata you want to get in. Some of it is pretty arcane, right, for the geospatial metadata. I think it would be great if the library community wants to get involved in that, and I guess some would. For other people, it's just so geeky that they'd rather not. But then other types of data have different metadata formats. It would be good to give guidance on what's appropriate for your type of metadata. Yep. Yes, sir, in the back.
Yeah, I'm interested in the thought behind the data discovery part. Because I do a lot of work with WMO with the YDOC system and their composition data, and the notion of trying to get to the point where you can discover the data associated with an application more than just seeing a catalog of the data set, but if I wanted CO2 data, with some other restrictions or requirements, and discover the data that way. Is there thought going on in terms of building that data discovery front end?
Yeah, let me just check if I have a slide here that I didn't show, which addresses exactly that. Darn, I kind of sanitized and removed the slides I wasn't going to use. I'd like us to set up a kind of tagging approach, and I have a slide that illustrates that. So we have 60,000 data sets in the catalog. It would be great to be able to say, we're having a crisis happening, like Deepwater Horizon oil spill, right? It was a major chore to find the data necessary for that, right? But it would be great if once somebody finds it, this is relevant, they could just tag it and say, okay, Deepwater Horizon people, this is important. And those tags just get kind of remembered by the catalog, and then you can say, show me all the Deepwater Horizon stuff, or show me the, I forget what you said, the atmospheric composition data, right? And maybe you as a researcher could tag things of interest to you, or maybe there could be an official, authorized tagger to put things for certain types of things. So that's something I really want us to try to make happen with the catalog. And I don't know yet if we can or what the right way is. But yeah, now I really regret I didn't include that slide. But good. I don't know who's next, but sir.
Just a question about, I'm just thinking, when you talk about these research development partnerships with some of the, commercial vendors, and, potentially they're looking at applications and things to use out in the market.
Mm-hmm.
How does doing security and all that figure into this? When you think about electronic hacking by other nations, and how does is that in the mix in all of this? Or I'm just curious.
Yeah, it's somewhat in the mix, but not as much as for some other agencies, because all of our data, or 99% of it, are public, right? So it doesn't matter if you don't have to hack into something to see it, right? It might be cumbersome, but it was already public, right? So that's great. The issue is more in maybe two other fronts. One is, how do you know the copy that's on the cloud is the same as the one there? What if it just accidentally got corrupted? Okay, so we're thinking about how to establish a better verification method using checksums or hashes, so you could tell if you needed to. So that's one. And then the other is, the real security thing is, if we're sending the data out and we're kind of allowing access to some of our machines, how do we do that safely? What's the right protocol for pushing data out or letting them pull the data from us that doesn't bog down our systems or make them vulnerable to hacking? So, yeah. But it's nice to not work with classified data. I hope to keep it that way. And I think, you had your hand up a little ago. I'll come back to you.
I had a brief comment to the librarian here. One thing you didn't mention is helping researchers get DOIs for their data.
Oh, good. Yes.
Because we're busy and we collect the data and write the paper and then we forget.
Yeah.
And so having experts who can facilitate that process.
Yes, that's a really good point. In fact, so at NOAA's case, the NOAA library is part of our DOI working group, and they help us there. If you send your data to NOAA NCEI, you will get a DOI if you want one, and we'll give you one there. Uh, Great, thank you.
So the hacking question leads, well, your answer to the hacking question leads to the whole issue of whether or not you're actually doing annotation on workflow and process and version.
Mhm. We do record provenance information in the metadata. We don't really have a kind of an additional annotation thing where people could comment on data sets and so forth. When we start talking about tagging data as relevant to some purpose and allowing people from the outside to tag, then there are kind of risks, right? People can write any kind of text. How do you know it's not going to be irrelevant or embarrassing or whatever? So that is an issue, and that's why we're a little cautious about that. It might be interesting to go through a non-NOAA group, such as ESIP, Earth Science Information Partnership, to handle things like annotation. So it's sort of, their servers, and they can worry about the kind of commenting, and they can moderate annotations and so forth. But in terms of the core provenance of the data, we're trying to record that in the metadata in a very formal way. Yes, please. Yes. Yep. Right. So how do we ensure data quality and accuracy? Yeah. So we actually have a information quality policy, which talks about ensuring that the data we send are of the best possible quality, and that the methods of quality control are listed somewhere, so you could actually go and see what was done as part of the quality control. It does allow for kind of raw data to be sent out before quality control, as long as you flag it as such. So one example, we have water level sensors, and you can get the current value right away, but the warning, disclaimer, this is not quality controlled. And then later, every month or something, they issue the formal quality controlled version. So so how can you be assured that it's accurate? Well, we're trying to make it as accurate as we can. Sometimes it's hard, right? A forecast, especially weather forecast. How many times have you been told it wasn't going to rain and then it rained, right? So forecasts are not always accurate, but the measurements we try to do as accurately as we can and send them out and give a lot of documentation, especially now in the climate arena, right? If we make a statement about global change, a lot of people push back on that and want to contest some of the findings. So we have to be really, really careful about demonstrating that the conclusion we came to is the correct one. So, all right, looks like we've. Oh, okay. The metadata rubric and the completeness. Yeah. Okay. So the metadata is basically an XML file, which asks a bunch of questions, and we have XML style sheets that just check, is this listed, is this listed, is this listed, and then sort of counts up those things and records them in a database as a function of time. So we can see is the number of these, is the number of things mentioned on average going up, and how many metadata records we have, and so forth. But so style sheets backed by a database is really how we do that. It's tricky because some of the metadata is not ISO, so we have to convert it from the FGDC format, and that sometimes loses some of the information. Something that would have had a great FGDC score maybe loses some in the ISO. The other question is, right now we're just checking for existence. So say somebody says as data access URL, www.noaa.gov, that's not very helpful. That's just our agency webpage, right? So we need to now get to the next level and look at what they are saying. in terms of all these things. So it's an ongoing process, but we fund, my office actually funds a little group in Boulder, Colorado, to work on that metadata rubric and just kind of improving it. I might even be, if you're interested in it, if you have ISO metadata, something that could be made available open source, but I'm not sure. All right. Looks like we've gotten to the end of the questions. Thank you very much for having me over. I really appreciate it.